programmer, I like putting things together into useful or fun things. Sometimes it's both. The ability to code something that helps me solve a problem is a very powerful and liberating feeling. However, there are times that a software solution is just not enough. Sometimes I might need something to mount the whiteboard on the wall, or I thought, wouldn't it be a good idea if I could have an extra shelf under my desk to stash away my laptop when I don't need it? Sure, there might be something I can buy to fix that, but sometimes off-the-shelf products just won't cut it. What if there's a tool that can allow me to build things physically? This is where I thought of a 3D printer would help. But that means that I'll need to learn how to do 3D modeling, and I'm not really fond of 3D modeling software. Is there a tool to create 3D models through something that is more in my element? Can I use Python? These are some of the things that I thought about as I delved deeper into the rabbit hole of 3D printing, 3D modeling, and putting it together with programming. My name is Matt. I've worked as a software engineer for the past 14 years, and I also teach Python programming in both community and industry settings. And I also serve as a volunteer for the Python community here in the Philippines. And one of my proudest moments was being recognized as a PSF Fellow member. But most importantly, I fancy myself as a peanut butter and coffee enthusiast. Allow me to begin with a story about how I got into this whole space. Programming paved a path for me to explore and experiment on things that intrigued me. As a child, I liked learning about how things work, taking things apart and trying to put them back together, sometimes successfully, most times not. But it gave me an odd sense of high. It also led me to a lot of bruises and trouble, but it was worth it. My first computer was the Atari 130XE. In the eyes of an 8-year-old, it was the most fascinating thing I have ever seen. The rest is history from there on. Programming enabled me to make my own tools and games, and led me to learn all about operating systems, networking, and virtualization. I fell in love with Linux and Python in college, and I went crazy with the smallest Linux installations I could manage, like DSL or Damn Small Linux and Puppy Linux, and installed Python into almost any platform I had access to. This is a Python Tetris clone I made fairly recently and loaded it into a Nokia Engage. I first heard about consumer 3D printing in 2012. The idea of being able to see something designed from your computer come to life got me really excited. The Star Trek replicator is upon us. The possibilities made me feel like an 8-year-old again. Alas, its availability and cost was out of my reach. I can only dream of having one someday. Then one day, during the pandemic, I thought I wanted to expand my hobbies into electronics and maybe build a PC with a Raspberry Pi. So I bought a Raspberry Pi and an electronics kit to start tinkering with. My tinkering led me once more to 3D printing, and saw a lot of neat Raspberry Pi projects done with it. I was also amazed at how accessible and affordable it has since become. Maybe it's time to get one. I'm married now, so I talked to my wife about it and tried to justify having a tool that can be used to repair most home stuff with 3D printing. Well, she's smart enough to see through my bullshit, but indulged me with no objections either. So wife approval, checked. This is my 3D printer, and Since then, I went deep into the rabbit hole of slicers, STL files, bed leveling, print speed, and quality settings, filaments, more bed leveling, while mostly printing toys and accessories I found on Thingiverse. One day, my wife wanted to use a second monitor for work. I had an extra monitor at the office and thought she could use that. When the monitor arrived, it turns out that it does not have a standard VESA interface that we can use to attach to the monitor mount for her table. Yeah, those proprietary mount systems, they suck. And so I searched through Amazon and Lazada for a VESA adapter and found one, but the price is almost half the price of the monitor. So, no thanks. I searched through Thingiverse if someone has already designed a VESA adapter for the monitor. I found one, but upon printing it, the measurements were way off. Problem? Nay, opportunity. Prior to this, I already started tinkering a bit in Blender and FreeCAD for parametric modeling, but they felt clunky and overwhelming. So I searched for something more my element and found out about OpenSCAD and a Python library that interfaces with it called SolidPython. 3D modeling in Python. So, what is OpenSCAD? OpenSCAD is an open source script-only CAD modeling software. It was developed back in 2010, and it utilizes this concept called constructive solid geometry, or CSG modeling technique. And this is SolidPython. So SolidPython is an open source Python library that generates OpenSCAD code. It also allows you to tap into the power of Python and its ecosystem when you're doing 3D modeling. Well, still, since OpenSCAD has also a vast ecosystem in of itself, SolidPython still allows you to utilize those third-party libraries for OpenSCAD. Now here's the meat of the concept: constructive solid geometry. So constructive solid geometry, or CSG, is the manipulation of basic shapes, or what they call primitives, through operations. Now these operations are either Boolean operations like creating a shape from the union of or difference of two shapes, and also geometric operations like moving and rotating shapes in the 3D plane. Now let's see it in action. You can install OpenSCAD via Snap if you're on Ubuntu. You can run it just by launching the desktop icon or through the OpenSCAD command. And it's also, since it's cross-platform, so there are also binaries for other operating systems. Now, SolidPython is just a simple pip install operation. The OpenSCAD interface looks like this, and it comes with its own text editor, and the file extension is called SCAD for the OpenSCAD scripts. Now, this is just a boilerplate that is good to build things on top of. It runs the Python SCAD translator and launches the OpenSCAD program with the generated SCAD file. the hello world of 3D modeling? Well, I'm not sure, but the cube is a nice shape to start with. So all you need to do is to import the cube function, and it gives you, you just feed it with a list or a tuple with three values in it. So it allows you to define the cube within the X, Y, and Z plane. So that was how you create a primitive. In that case, it's a cube. Now let's try adding some color. Now it's our first operation, and we import the color function for this one, and then we just wrap it on top of the cube. Notice that the shape is wrapped inside the color operation once it's been translated back to SCAD. Now, there's a translate function that enables us to move the shape within the X, Y, and Z planes. From here, you'll notice that the Python code, in the Python code, each function returns a SCAD-compatible object. And we just tend to use that as an input to the next function, resulting to this wrapping of primitives and operations once it's been translated. Now let's try another shape. The cylinder normally lays flat in the x-axis, but utilizing the rotate function, we can reorient it minus 90 degrees from the x-axis. Now the real magic starts once you start using simple shapes together to create something new. Here, we use the cylinder to punch through a hole into the cube by performing a difference operation between the two. Alright, now that we know the basics, it's time to do what we came here for. Let's model the VESA mount. Now the VESA mount is split into two parts. The first part would be the monitor adapter and the VESA mount itself. Okay. So the monitor adapter is the one that we will is the one in the red color. It's the one that hooks in the latch beneath the monitor, and then the VESA mount is the one that we attach to the VESA plate. Okay. And this is how it looks like once it is attached. So the monitor adapter attaches to the latch at the bottom of the monitor here, indicated by the red box, and while the VESA mount is screwed together with the VESA plate indicated by the blue box here. Now let's explore the creation of the monitor adapter shape. I'll spare you the boring details, but I've split each primary shape into their own function and created this adapter that matches the monitor's latch, this particular shape here. Now, it took me several prints and measurement adjustments to get this part right. The technique was to only print the part that attaches to the latch before committing to the whole object to save on filament. So this particular part, I had to do a lot of trial and error And once it has like hooked in perfectly, then I committed towards printing the whole shape. Now you'll also notice, since this is a 3D print, you also need to be creative with strengthening the design. So in this case, I had to create this X shape here just to add a bit more strength for so that it would be able to carry the weight of the monitor. Now let's see. Now let's create and design the VESA mount itself. This shape is pretty much, it's more straightforward to design, but it taught me how to use the hull function, which is used to fill out the space between two objects you want to put together. So this mount, it actually uses two triangle shapes. So this is one triangle, this part here, and then there's a hidden triangle on this part here. And then once you use the hull function between those two rectangles, it created this, it filled out the space between them through this slanting shape that you see here. Okay. And then I just used other shapes to well, the same cylinder technique that we did to punch through the holes that we have here. Now let's put the two shapes together, or the two main objects together. So this is what the whole product looks like when they're combined. It was a little tricky to get the items aligned to ensure that the screw holes that go through them is still lined up properly. So yeah, I had a bit more trial and error on this on these parts here. Alright, now that everything looks like in order, let's print this thing. I printed the mount first and ran out of filament on the last layer. It's almost finished and I ran out of filament here. Good thing though, good thing that you can pause the print and attach another filament. That's all. So I also have a filament that's almost used up lying around. So I attach that, and it looks like this now. In hindsight, I accidentally experimented with this concept called multicolored printing in this way. Finally, I loaded another roll of black filament and printed the adapter. Now, I think the whole thing, the mount and the adapter, took about 8 to 9 hours in total to print. I forgot, but yeah, it's about that much time. So it takes a long time. And now, for the moment of truth. I attach the adapter into the mount. You'll also notice that I've strengthened these latches with super glue just to, I don't know, to make them last longer, because I tend to take it up, put it on and off of the monitor latch, and that adds stress to the material. And it's a very thin strip of plastic here. And then the mount, I've screwed it into the VESA plate. Now I've hooked it into the monitor. This is really starting to get very exciting at this point. And I've finally attached the whole thing into the monitor stand. There's no greater feeling than seeing your creation come to life. Plus, the feeling of being cool in front of your wife. This is it. I can do anything. Until one of the latches that attaches to the monitor broke off. Nothing that a super glue won't fix. Until my wife tried it out and it was positioned too high. No problem. I haphazardly designed a patchwork extension to lower the position of the monitor. However, this just made the monitor start bending from the weight. Made the mount start bending from the weight of the monitor. I am so crushed at that point. And I thought, I need to rethink this. So back to the drawing board. Much like programming, design is an iterative process. However, unlike programming, it's much more difficult to ascertain the effectiveness of your solution until you've printed and tested the design. And 3D printing, as you've noticed, takes a long time. So from here on, I've made more improvements to the design of the mount. I've made a longer mount board. I've also segmented screw holes to make it easier to adjust the positioning relative to the user's eye level. So I've also made it compatible with both 100mm and 75mm VESA mounts, if you notice here. I've also improved the strength to handle the weight of the monitor by adding these fins at the back. I've also added some custom spacers in case the fins would obstruct the screw path of the mount into the VESA plate. So it took me a few days to play around with these designs and learn a lot about OpenSCAD's different functionalities. Redemption. So finally, my wife's able now to use it. And I'm able to use it. And it's still a work in progress, but this has worked much better than before. And I'm glad to say it has survived rough handling and a few earthquakes without breaking a sweat. This project made me realize and appreciate how costly and time-consuming the R&D work must have been in the things that we use in our daily lives, like the ergonomics of this mouse, this dual plug USB drive, and even this dual screen phone. As a programmer, it made me more conscientious in writing code that my teammate and future self would appreciate, and design solutions that will be more intuitive for my users. It also made me appreciate what 3D printing brings to a household. Manufacturer creates proprietary monitor mount that plugs you into their ecosystem? No problem. Build an adapter yourself. And that's just the tip of the iceberg. That's it. If you have a 3D printer and have tried 3D modeling or haven't tried 3D modeling yet, go check out OpenSCAD and Solid Python. If anything else, I hope this encourages you to try new things and expand your skills. With the ever-growing accessibility of consumer 3D printing, your programming skills now enable you to become a maker of things too. Thanks for listening, and catch me in any of these links, and I'll see you around. See you next time.